Hello, welcome again to part 2 of algorithms, using algorithms with flowcharts, pseudocode, and a little bit of coding with Python. This is part 2, and I called it by 7. Just that's the number the word I could think of. But it basically you draw a flowchart for a program that calculates and displays the remainder when the number entered is divided by 7. So for example, 8 divided by 7 is gonna give you a result of 1, because if you divide 8 by 7, the remainder is 1. Okay, so that's what the program is supposed to be doing. So the program must allow the user some time to read out the answer on the screen. The number has to be greater than 7. Okay, and the number entered must be an integer greater than 7, of course. Yeah. Okay, so that's a flowchart. That's a pseudocode. Now pseudocode, really, there's no right or wrong way of doing it. It has to make sense, and it shouldn't be code. Okay, it should just be sentences of English. It should be a cross between a normal language, or perhaps English or French or whatever language you're using, and code, the actual code that you use. You can also use some symbols, Now ignore all these, hang on a minute, ignore all these double arrows, okay? These in Python are used just to show the start of line, but they don't mean anything. They're always ignored. In pseudocode, we say the first number, we call it num, is equal to enter whole number, which means enter a whole number that is greater than 7. That's the first instruction you get. Then it's going to say if the number you've entered is valid and greater than 7. By valid we mean, is it a number or is it just a letter? Like instead of 1 you wrote I. Then divide by the third line, it says divide that number by 7. Find the remainder and display the remainder. Otherwise, print an error message. You can expand on this pseudocode, make it even more detailed. I just gave you this to give you an insight, or just a little understanding of it. Same with the flowchart. It starts, then you have this parallelogram. There is an input and output, and it says enter whole number bigger than 7 or greater than 7. Then it's going to check. That's a decision maker. Well, what this does is to check if the number is valid. Is it a number? Is it greater than 7? And is it an odd number? I mean, it could be an even number. Still, the answer would be a 0. Okay? Because there will be no remainder if there isn't one. Alright, anyway. So, for example, 14 divided by 7 is going to give you a 0. Yeah? 15 divided by 7, it definitely has to be greater than 7. Okay, if it's a 7, you're still gonna get an error message, but that's okay. Okay, so divide the number by 7, find the remainder. That's our process. It's a background program that runs now. But if a number is not greater than 7, it's gonna show an error message, wrong number entered, and then it gives you another chance. Now in between here you can say refresh the screen, delete everything on the screen, refresh the program, and then ask them to enter a number again. Alright, so there is a lot more to it than, now this is just a basic. For example, for the year 7 class, for beginners, okay, if you're more advanced you can expand on this flowchart, make it even more complex. So the number is divided by 7, you find the remainder, and then you display the remainder, and you end the program. That's how it shows. Now let me show you the little bit of a code for it. Okay, now the code here, we start by defining a function. This function is named enter num. Okay, and then we're going to make it a global variable. Num is a global variable because this variable can be used anywhere. Okay, however, you probably might not need it. Now num is equal to integer, so we're going to convert whatever they type into an integer. Okay, and then it's an input because they're entering data. So, and this is an instruction. It says enter whole number greater than 7, and then you leave a little gap here. So that's what is displayed here, greater than 7 and a little gap. Then remainder equals num modulus 7. Modulus is only gonna give us what a remainder would be if a number or a certain given number is divided by 7. Now, and then after that, it's gonna format everything inside of this. So you write f there, then quotations, and you write num, which is a variable. Remember, it's an integer type. And then the words divided by 7 leaves a remainder of. Now, those words are a type of string, which is why we put an f here at the start to format everything into a string or into the same format, right? And then remainder. Remainder can also be an integer, or it can be a float. It can be any data type, but it's a number anyway. Okay, so group all of them, format them, and then we print them off, display them on screen. That's an input output here. Now this function is defined, and that's what it does. Okay, that's its value. That's what it does. For it to run, you've got to invite it, you've got to call it. So we're going to use a try and except. This is called exception handler or error handler. Now you can try running the function. However, if there is an error or a problem, you throw an exception and you say try this function, what it does. Now suppose someone typed ABC. Obviously it can't be an integer because they're letters. All right, so it's gonna throw an error message. Now rather than the default error message shown by the computer or the program, I'm gonna write my own error message. I'm gonna say except. When the function fails, except print you have entered an incorrect value. That's my error message. Okay, and then \n is for a new line. That is then going to invite the function once again. So it gives you another chance after chance. So it's never going to end until you enter the right number that is greater than 7. Now you might notice there's a little problem here. If the number is 7, the function will run, okay, because there's no condition that says if num greater than 7 do this. Okay, there's no such condition because we use a try and except. If we use an if and else condition, so elif, then we would add in conditions where a number has to be greater than 7. Okay, it's got to be greater than 7. So basically this is just a beginner's way of coding this. You still get some marks. You actually get marks for this, but if you want to make it even more professional or more detailed, you can add more and more exceptions or more conditions so that what was asked is answered. But this leads you up to a certain level of points. Okay, result screen. Enter whole number greater than 7. You write ABC. You have entered an incorrect value, and then you write a whole number greater than 7, and you get 14. You write 14 here, and 14 divided by 7 leaves a remainder of 0. Yeah. Now in a case like this, you would have only answered a few things. Okay, well, the majority of them, but there's things you've left out. For example, where does it detect if the number is greater than 7? Where does it detect if the number is equal to 7? Okay, so these are all things that in your free time. I mean, I'm not gonna do the whole thing from the start to the end, but I give you just a kickstart for you to add in whatever you want to add in so that the question is answered or the task is already completed. This is just for you to have an understanding of how to go on about coding this. The main point here is about the flowcharts and pseudocode. Okay, so this is what it is to answer a task like this. Okay, using algorithms. That's the flowchart and the pseudocode to the other side. And whatever thoughts you have, and whatever you want to add in or expand on it, this is just a kickstart, and it helps you to understand how flowcharts can be used. Okay, see you in the next part, and I hope the next part is gonna be showing you something even more interesting. It will be about a countdown timer. Okay, yeah, thank you.